Hi, we're just going to start in a couple of minutes. Just bear with us.
No, I'm just doing a quick sound check. How does that work? Okay, not too muffled. Okay, great.
Hello, my name is Tom Webb. I'm a postdoc at the University of York studying the coastal cryosphere. I want to welcome you all to the Cryosphere Pavilion and this event on Antarctica and the limits of adaptation. I want to welcome those of you watching virtually, including the Cryosphere hubs in Stockholm and also in Geneva. You'll have a chance to pose questions in the chat. For some of you, these will be at hubs directly to speakers and during the question and answer period. I am now handing over to Ben Strauss from Climate Central.
Well, thanks so much for having me. And it's an honor to be here after so many great talks earlier today, getting into the details of the science. What I'm going to do is more of a slideshow to try and show the most tangible implications of the kinds of science that we were talking about, to put those numbers and ideas into pictures. So everything I'm going to show today, you can access via the URL currently on the screen, picturingourfuture.org, and it's pretty self-explanatory. So I thought I would start here in the UK. What I'm going to show in the coming slides is a series of scenes and maps based on scientific projections of committed sea level, meaning sea level that we put in the pipeline, that we lock into if we warm the planet by 1.5 degrees or 2 or 3 or 4 and so forth. That's Celsius. And these are based on what really, in light of some of today's talks, might be slightly conservative projections, but it's peer-reviewed literature. It's been in the IPCC reports. And this is going past the numbers to what it looks like. So we'll start again with Buckingham Palace in London. And here's a look via Google Earth at the scene as it appears today. And now I'll move to sea level rise already in the pipeline from the warming we have already experienced, 1.1 degrees Celsius, okay? So you can see, just if you watch carefully in the corners, I'll go back and forward, you see a little bit of water creeping into the image. So why don't we look at our big goal, 1.5 degrees. There's 1.5 degrees. That's the legacy at Buckingham Palace of 1.5 degrees. But let's take it a little further to 2 degrees. There's a nice look at 2 degrees. And we keep on moving up to 3 degrees, our current track. And by the way, when you look at the Climate Action Tracker and other resources like that, and they say we're on a track for around 3 degrees, that's actually 3 degrees by 2100. In the 3 degree scenario, we're still emitting a lot of carbon in 2100. So we're actually, the 3 degree track is really probably a 3.5 degree track or something like that by the time you get to where we get to net zero emissions. And here we go to 4 degrees for Buckingham Palace. That's, we say we're on a 3 degree track, but if we're a little unlucky in terms of the how climate sensitivity to pollution gets realized, we might be closer to a 4 degree track. All right, now we're going to go on a little bit of a tour around the world. Not a lot of talking, but just trying to share this sense of what these different warming scenarios mean for our cultural heritage at places around the world. And, as Rob and Jonathan and others were saying, Twyla, these are not projections for what's happening, the day we get to 1.5 or 2 degrees, right? These are multi-century projections, could be 200 years or 500 years. We don't know just how fast, but we put them in the pipeline, right? And when we think of Europe, when we think of Asia, at least the old world, right? These are places that have cultural legacies that last backwards in time, not just hundreds, but thousands of years. And so think about, when I look at these images, I think about how our descendants will remember us and what we did, okay? And will they remember us as the people who gave them a necklace of drowned ruins around the coast of the world to remember them by, or as the generation and the time that stood up and made a change so that didn't happen and we transitioned to a clean energy future? So now, quickly, here's a look at the map behind that. In this map, we're comparing the areas in purple are areas that would be below the future high tide line. That's already in the pipeline, 1.1 degree of warming. The yellow shows the increment up to 1.5 degrees. Here's 1.5 in the purple, the yellow goes up to 2. and here it goes up to 3 in the yellow, and here's up to 4. So this map, for instance, the yellow shows what you save by restricting warming to 1.5 versus 4 degrees in terms of what's above the tide line in London, right? And so this map corresponds to the images I just showed of Buckingham Palace. A little closer to home, here's us where we are after 1.5 degrees. Here's 3 degrees. So this imagery is coming from Google Earth. There are 3D building imagery with, again, science-based sea level projections layered in there. And we took work done by Anders Leverman and colleagues and generated local projections and refined it just a little bit to do this. Before going through the rest of the slideshow, I'm going to ask your indulgence. This is a 2-minute video, but it's really worth checking out. So with my hostage audience here, let's give this a try. I don't know if I can hit play or if you have to hit play. So that kind of says it in a nutshell. Help us to show this to as many people as we can here at this convention. It's one of our small missions here. Continuing the tour, we have some beautifully reconstructed photographic images. These are places lacking the Google Earth data mostly, but we worked closely with an artist to get the sea levels just right. So here's Shanghai. China has a little stake in this. Here's Guangzhou, 1.5 and 3. That means the camera is underwater and looking up through it. The map of the Shanghai area is quite astonishing. And here's Shanghai. So you can see we're talking about multiple whole cities below the 1.5 level and a lot more below the 3 degrees Celsius level. One interesting thing you'll notice is that Shanghai seems to be a little island of yellow, somehow protected from 1.5. All of these maps are based on elevation data that Climate Central developed using machine learning to improve on elevation data from NASA and other sources. The problem with all global elevation data sets is it's based on satellite sensing that can't tell the difference between treetops and building tops and the ground. So we were able to correct for most of that bias, but there is still some residual challenge, for reasons I won't go into, in the densest of urban environments. I think Shanghai looks like an island there only because it's full of high rises and skyscrapers. And that if you really had the truth, it would be purple too. So Saudi Arabia is in the midst of building the Jeddah Tower, which is meant to be the world's first 1 kilometer high building. It's about halfway. It would be a shame if its toes were wet. Here's the world's current tallest building. And here's the future after 3 degrees Celsius warming. Now, this talk is about the limits to adaptation, and some of these places, none of these images are imagining levees that might be built in the future, and some places will build levees to defend. Dubai probably has as good a shot as anyone, because one of the problems when you build big levees is what happens if it rains behind the levees, or if there's a river trying to get out, and that's not really a big problem in Dubai for the most part. But how deep a bowl do any of us want to live in the bottom of? What happens if the levee fails, right? Assuming you're a rich enough country to build it in the first place, what happens if it fails in a catastrophic storm? What happens if it fails in an attack from an enemy power? If you're living 2 or 3 meters below sea level, the flood would be instantaneous and deadly. So I'm not sure many of us would choose to live in a place like that. You can build in pumping systems to deal with rivers and rainfall, but those pumping systems would have to never, ever lose power or fail in any other way. Here's the map for Dubai. Again, purple is below 1.5 C, yellow is below 3 C. Pretty much the whole metro area is in the crosshairs here. A bunch of important religious locations. Here's the Central Mosque in Lagos, Nigeria, 1.5 and 3 degrees. Here's a map of the area. Lagos may have a buffer if we can stop at 1.5. Here's an old cathedral in Havana, Cuba. Camera gets below water. Temple of Literature, 1,000 years old. Hanoi, Vietnam. 3 degrees. Vietnam is one of the most threatened, probably the most threatened major nation in the world, vying with Bangladesh. And the map of South Vietnam and the Mekong Delta looks even worse than this, but you can see Hanoi, the city center seems to be spared. I believe this purple to yellow transition because it's not a yellow island, it's a gradient. So, but there's a huge amount of development that's affected at 1.5. Here is the Maldives, small island nation. And we're below water level from the camera. I'm not going to even show a map there because it's just all purple. Bangladesh, all the way up in Dhaka, after 3 degrees. And it's interesting here, you see Dhaka, we've got another little yellow island effect. I don't know if that's real or not. But interesting is to zoom out to all of Bangladesh and the amount of area already below sea level with 1.5 C. I'm sure that's not a surprise to people here, but the scale of it is really astonishing. Here's an important building in Mumbai, 1.5, now 3 degrees. And the map for Mumbai Great deal is lost after 1.5. St. Petersburg, Russia, 1.5 to 3. St. Petersburg has an interesting map because there's very little effect at 1.5 degrees. But when you get to 3 degrees, you lose pretty much the whole city center. And there are some places like that. Here's Cape Town, South Africa, 1.5 to 3. There's a lot of mountains around Cape Town, but a core part of downtown is highly threatened. Rio de Janeiro. Here's the map. Victoria, Canada. Oops, missed a slide. And back close to home, Washington, D.C., 1.5 and 3 degrees Celsius on the steps of the Capitol. And here's a look at that map. So the whole Smithsonian, Green, all of that area in danger. I just wanted to finish by wrapping up. I've showed these very long-term, multi-century in the pipeline projections, and I know that's the longer-term theme here at the Cryosphere Pavilion, but I just wanted to share there are other maps and views. For instance, much better picture for Mumbai, just looking at sea level rise projections through 2050. But if we change our interface to changing other settings to look at sea level rise plus a annual flood, typical worst of the year flood, a great deal is below that level just by mid-century. And I'll also advertise that there are many other flavors of maps that you can look at. We were looking mostly at the warming choices map. This is the year map, and I'll point out in particular the ice sheets map lets you see contributions just from Greenland or just from Antarctica with their spatial fingerprints, like Rob was just talking about the difference in, just to play with that. So that's what I've got. You can find everything I just showed at Picturing Our Future, about 1,000 images in total. I showed you only just about half. I think now maybe we move into panel mode, or have a, I don't know how the group wants to do it. Later on, there might also be the possibility, if anyone wants to look at a particular geography, we can interactively look at maps from different places. But I think when it comes to adaptation and beyond adaptation, you know, the main things I think about are how deep of a bowl do we really want to live at the bottom of? Some places won't be able to afford to build the protections. Some places won't be able to just because of their geography. It's too complex a geography, or the bedrock is porous, like in South Florida, or you look in Bangladesh, you have deltas with compacting, sinking land, or very complex long coastlines. Seems a lot less likely to happen at the scale that would be needed. And finally, I think the critical question is speed. And I like to say that if I were holding a bullet in my hand right now, I don't think any of us would feel very threatened by it. I mean, even if I threw it at you, you wouldn't feel very threatened. But when it's fired out of a gun, it travels so quickly that it's extremely dangerous. And the same thing is true with climate change and with sea level rise. It's really the speed that makes it dangerous. And so if we can stick with 1.5, even though there are a great deal of areas that are deeply threatened and likely condemned by the sea level rise we would eventually see, we would also be buying them time, because sea levels would be more likely to rise more slowly in those cooler scenarios than in the warmer scenarios. And with time, there's the chance to adapt, there's the chance to relocate. I finally, philosophically, I'll say that, you know, each of us walks around with the knowledge that we're mortal. I think this is important, right? Because those of us in this room like understand these big things, these big dangers, and it can feel overwhelming. But we also all walk around knowing that we're mortal, and that does not stop us from leading meaningful lives, right? I don't give up and do nothing just because I'm mortal. Well, we do have some coastal cities in the world today which are mortal. They will not be cities in 100 or 1,000 years. It doesn't mean that they can't have very meaningful existences between now and then. And, you know, if this meeting does its work, more of them can be saved and protected, and we can slow down the process so that the end of life process for those cities is more humane, is more just, is less damaging and impactful. And I think that just that is a very meaningful and important aim by itself. So I don't know, Rob, Jonathan, I don't know if you want to do questions, just come up and do a panel thing.
So thank you very much for your talk. It was very insightful. So I think we were thinking that we'd do a panel with Rob and John and yourself. So we'll just grab some chairs now.
Okay. And I.
Get the ball rolling, and then maybe we could take some things from the audience.
Are you going to ask questions from?
Yes, I am. So, do we have a question straight away in the room? If we've got a question straight away in the room, okay. This one's live.
Oh no, but you
Sorry.
want that for the questions.
Oh, okay.
I got, there's this one, and then there's that one.
Yeah, we won't use that. Yeah. I think I just want to sort of emphasize one of the things that Ben mentioned. You know, this session is about committed long-term, you know, the ultimate commitment to sea level rise that we're facing. But in terms of our ability, humans' ability to respond or adapt to that sea level rise, it is all about the rate. It's not about, well, for in terms of our response, it's all about the rate. And that is in our control. You know, I mean, we are committed to ultimately to meters of sea level rise long term, but the rate is in our hands right now. And I think that's something that we have some control over. And, you know, if the current rate of sea level rise is about 4 millimeters a year, that's 3 times larger than it was for the whole of the 20th century. And I think, you know, that's probably kind of close to the limits of our ability to adapt to. So if we go much more than that, if we get to like a centimeter a year, then we're really in deep trouble in terms of our ability to respond to that. So I think we have a question. Or
are there any questions online or the other hubs or in the room? So
I think by what you just said, you clarified what I was about to ask. Because what came up one of concern when I was following the presentation, like when talking about sustaining the ecosystem in Bangladesh, so they can manage the adaptation towards what is coming. So mangrove was the main, the mangrove ecosystem was the main to enhance. But with this scale, as you just said, I mean, no ecosystem can stand. And I mean, one of the things like of adaptation is the immigrants to different latitude, for instance. But given the rate, it all depends, as you said, on the rate and the how fast it is, because otherwise species are not going to adapt in couple of years or in couple of decades. It takes we are talking about some species might not be able to adapt, and some might take centuries. So if the rate was really fast, then we are definitely gonna, I don't know, that's was my.
Do you want to talk about milk whispers, May? Oh, go on.
Talking, I'll just say briefly, it's an interesting question looking to non-human species, and who are less able to adapt than we are for the most part. When you talk about mangroves or coastal wetlands, I think, I mean, there is a lot of history of sea levels rising and falling, and sometimes rising quite quickly, and with coastal ecosystems ultimately able to track, but they need a place to move. and so if it's an entirely populated area, a developed area, right, that's difficult. I think the mangroves can never stop a sea level rise like that, but if they can be allowed to migrate uphill and inland, they would still provide a very valuable buffer against, say, worsening tropical cyclones. So I think there is value in looking toward that kind of green infrastructure, so to speak. I mean, really, protective ecosystems, and trying to make sure that there's room for them, even as sea levels rise. But no, they're not. They're just going to help soften a transition. They can't stop any kind of sea level rise like we're talking about today. So I'm very sympathetic to all the conversations that go on about using green infrastructure and not gray infrastructure, or not just building to protect against sea level rise. And in my heart, I wish we could do it all that way, but my head knows that with these kinds of longer term sea levels, I mean, the future is one in which almost every nation is likely to invest in building kind of massively engineered coastal defenses. And but I think the more we can, and that's not a preference of mine or advice that I'm giving, but I think it is an inevitability. But the more room we can give for nature to be with that and to move with moving sea levels, I think the better off we'll all be.
So we've got another question just here.
So there's so much kind of knowledge, awareness that's held within this discussion of the science, and also Climate Central doing so much to try to bring this to people. And I wonder if each of you might kind of, or not all of you need to, but I'm interested in your reflections on the progress the challenges and perhaps those kind of opportunity space or aspirational bits of really connecting the scientific knowledge with those on the ground making decisions, both in how we might struggle to connect the wide ranges of scientific projections, at the same time connecting how much we do know and how much we can depend on how we're looking into the future, and looking a little into these connections outside of the scientific community.
Sure, I can kick this off. Sure. Yeah, I'll try to kick this off, Twyla. It's a really great question. Scientists need to start working with, truly integrated with engineers, with social scientists, with people who understand policy and governance, environmental law. We haven't been working in an interdisciplinary way long enough, I don't think. I mean, this issue of rates, it seems really obvious, but if you look back 10 years, all the projections you will ever see are just of magnitude. Nobody was talking about rates. And I mean, that just, now it seems kind of crazy. And I think there's like non-traditional sources of knowledge and wisdom that can be drawn on. Like, for example, Indigenous knowledge. So, there were people in North America, for example, living at the water's edge for millennia, right, as sea level had been rising, like through the Holocene. And, they were having to deal with retreat, with all kinds of issues. And in some cases, there are deep, like oral histories of some of those challenges. So I think there are even like some really interesting non-traditional scientific sources of information that need to be integrated too. But this notion of us like just passing off like sea level projections to another community to deal with it, that's just hasn't been working, right? And I think we need to be working together and more face to face and with the social scientists and with the engineers.
So, I mean, I very much agree with what Rob said there, and I think a kind of catchphrase of the moment at the minute in terms of impact studies and impact analysis is what we call co-creation and co-production, and I think that is very important. But I would also say, perhaps I'm going to slightly disagree, that I think, and particularly with this assessment report, the 6th assessment report that the IPCC has conducted, I think they've actually done a pretty good job of synthesizing and assimilating the state of the art on what we know about projections, what we know about past sea level. And I think that actually is a really useful document for policy and a kind of benchmark effort in sort of encompassing current state of the art. It will become out of date. Maybe some of it is already out of date, but I think they have, we shouldn't underestimate the effort and the contribution that that's going to make.
I'll throw in a few thoughts. One is just that this is hard. It's very hard. It's hard for the scientists. It's hard for the non-scientists. At Climate Central, I mean, our mission is really to try and bridge the gap between science and the non-scientific public. And, one of the things you quickly learn when you're talking to the media or trying to convey climate information through the press and public channels is it's very frequently misinterpreted or misunderstood. I mean, we work to make sure to try and minimize that, and I think we do a decent job, but no matter what you do, there's going to be some degree of confusion and misinterpretation. I think there's work that the lay public kind of understands, but there's more work to do to kind of appreciate a scientific process of changing assessments. And one thing I hear from policy makers and planners a lot is they want to know what's the best number. Like how much do I have to plan for by year X? Like, just give me one and keep that one the same, for the next 5 years or my project. And I think any of us who like read the paper or watch TV or whatever, think about diet for a moment. I mean, 1 week wine is terrible for you, and the next week it's great for you. And the same thing with coffee or chocolate or a million other things, right? We're quite used to seeing science and scientific guidance, at least in medicine and diet, changing a lot as different studies come out and the state of the knowledge evolves, and also to some extent, researchers and enterprises with different interests or angles put different information kind of into the sphere. And I just think that's a reality because science is a living thing. Unfortunately, our planners and policymakers are going to have to live with an evolving state of science. One of the reasons why I think the perspective of committed sea level rise is really useful. It's a tricky concept, and for some it might make you feel, oh my gosh, we're doomed, like this is happening anyway, but or be a kind of turnoff. But to me, one thing it does is it says, look, if you're a planner trying to protect your neighborhood or your city, anything you do, right, is not going to be in vain because whatever sea level you're planning for, that sea level is coming. I guarantee you, no one is doing work today on sea levels higher than anything that will come in the future. And it wouldn't make sense, right? So I think that's an important message. Whatever you're doing, it's in the right direction. But there's a second very important element to that, which is whatever you do, you can't think of it as the end point, right? It's just one step on a journey. And one thing I see a lot is people, they do want to know, like, what's the number in 2100 or 2080 or whatever. Like, I think cognitively we want to like know what's enough. And if we do that, we're set. And it's just not that way. So if you're getting a right of way to build a levee and you're of a certain height to protect against 50 years of sea level rise, maybe you should acquire a slightly wider right of way or make a plan, understanding that one day that levee will be twice as high as the height to which you build it. Like, do what you're doing in a way that is one step on a longer journey. And if you can frame your planning like that, I think there's a great benefit. But, I just think this scientist and a planner, scientist and lay public dialogue is something that we are going to be wrestling with and going to need to invest a lot in over many years. I think the resources that we're throwing at this problem, the scientific research or the planning or the communication between the groups, it's all a small fraction of what we will need. And where Mother Nature, amped by us, will ultimately drive us to go. But hopefully we get to the investment in foresight sooner than later.
We have a few more questions.
For me, I think one of the key things of this, I mean, when you're talking about the limits of adaptation, one of the, I would say, most important moments in the June SB meetings was when there was a presentation on adaptation. And for the first time, I at least had ever heard in an adaptation dialogue, there was explicit mention that there are certain levels, certain things to which no adaptation is possible. We really need to focus on mitigation. And that's in a way that, the whole purpose of this pavilion, in a way, is sort of making clear where those thresholds are, making clear why it's so important. And so it was interesting to me through this mitigation lens, through trying to motivate ambition, the difference to the way we've normally presented this which is the way you did it in your stills presentation of first showing 1.5 and then 3. The film started with 3 and then moved to 1.5. And I found that much more effective because it sort of said what you could save. And I'm wondering if anyone else, maybe in the audience or maybe among the you two scientists had the same sort of reaction, was like, oh, this is so much better. And it might be a much more effective way of putting things forward in the future. So I'm just, looking for commentary, I guess, from both of you on that, if that felt more effective to you, because it did to me, and I was surprised at that.
I totally agree, Pam. Totally agree.
It's on purpose that we went in that order, precisely for that reason. It's interesting. I've fought with like a bunch of really smart communications consultants on the slides, on PowerPoints, who've always told me, no, I used to always go from like 4 to 2 or 3 to 1.5. And people have sometimes found it to be confusing that when they see the first one, they don't understand that something is wrong or different sometimes, depending on the scene. But, actually, if I had more time and I could do it again for a presentation where I'm showing lots of slides and you can, when there's a chance to really explain it, yeah, I agree. And that's exactly the purpose, is to say, hey, this is where we're headed, but here's what we can do. Here's what we can achieve.
Okay, thank you very much. There's another question here.
I'll just yell. Oh, okay, great. Okay. Yeah, it's just a quick one, and it's a bit of a tangent, I guess. But I was just really interested to see those pictures, I guess, because I've used the mapping tool in Talk to the Public for a few years now, and so I was kind of thinking that's obviously really impactful to have those pictures. So I was just wondering if have you thought about, or are there any plans to maybe expand that kind of approach to different climate change impacts? I guess I was just thinking from the perspective of working on permafrost and, these issues of kind of collapsing ground. And obviously that's completely different and it has a whole bunch of different challenges. But I was wondering if you'd thought about taking that idea further.
That's a great idea. I've thought about it, but not deeply, because it's a lot harder in the areas that I've thought about. I think one thing I would love to be able to do, but it would be such a huge project, is to show how the character of vegetation is going to change in places, right? Like California is going to change from a place that supports forests to one that's mostly grassland, right? And like on the peninsula in the Bay Area, total shift in character. To like somehow show people a picture of, here's your beloved like tree-filled place, and here's how it would look if it were a grassland, and that's where we're pointed, would be so powerful. But as you can imagine, much harder, like in both in terms of the projection and in terms of the physically creating the imagery. I will, since you asked the question, take a moment to make a quick, like we actually are beginning a project now to try and greatly expand the work that I just showed you by literally, the Google Earth images you can go on Google Earth and do quite efficiently. The photographs, each one is handmade. It's slow and expensive. And we have designed an instrument for car top to drive around neighborhoods like a Google Street View cam. And any house we go by, like we have like video game software package to simulate the appearance of water. And we can render within a second any water level to look like real water at your house. Like, what's that sea level projection? And we're raising funds to basically try and drive the eastern seaboard. I mean, ultimately, it's something that can be done coastally and inland and internationally. So at least you get to inland flooding, not just coastal, as one.
Thank you. I don't know if there's any more questions on the floor. I actually have a question. I was just really interested, Ben. I saw that I get the impression that you're really interested in preserving cities, and it doesn't really, even in quite extreme sea level rise cases. And I was just wondering if you could just comment more on that. Is there a threshold, a temperature or sea level threshold, where you don't believe it would be worthwhile to preserve the existing city?
It's a great question, and I think it depends entirely on the individual city and its topography and its kind of gifts or curses of geography. Miami is gone already because of the sea level rise that's in the pipeline and because it's sitting on porous bedrock, and you couldn't really build an effective levee to begin with, and to get so much rain. So no, I think it's going to vary from place to place. And if the rate is slow, cities may be able to crawl uphill or relocate over time. I mean, the secret about me is I'm really like a mountain and biodiversity guy who ended up studying like low, flat coastal cities. It's really motivated by an interest in climate change more broadly, and I think, part of what we're trying to do here is get the world to listen and understand the threat. And I think by focusing on cities, and this is just my own parochial, right? A lot of people live in cities. I think, when I started in sea level research, all the papers were about how the wetlands and marshes were going to suffer from sea level rise. And I actually care about those things, but I knew that like most people wouldn't. But if we started talking about cities, they would. And that's kind of where this emphasis came from for me.
Insightful.
Yeah.
So I would like to thank all of our speakers today. Well, I'd like to thank the whole panel today, I should say, and Ben for speaking. Thank you very much. Will you join me? So if you would like, feel free to stick around for our next event. It's at 7:30. It is the Cryosphere Cayley, Global South and Cryosphere Facing Crisis.